Cool. Let's start. Thank you all for coming here. So, today, WebAssembly and Kubernetes. They asked me to the talk, and I asked colleagues of mine, what talk should I do about? And there's one colleague that said, do one about WebAssembly. And I was like, what is WebAssembly? And he yelled, yeah, that's right. Do a talk about WebAssembly. So, these past couple of weeks, I was learning WebAssembly. Okay, so this talk will be about my journey about WebAssembly and how to use it on Kubernetes. Because we need to use it on Kubernetes, right? So, a bit about me. Currently, I'm a DevOps team lead, okay, at xgeeks. Also an academy mentor for DevOps Academy that xgeeks also has. And life takes many turns, and also now a YouTuber. So, like Victor said, like and subscribe. Yeah. So I have videos about Kubernetes, more specifically on the multi-tenancy and how can we be more efficient with it in Kubernetes. So, what is WebAssembly? Or WASM for short. I'm going to use both terms, okay? Raise your hand here who knows what the WebAssembly is. Okay, okay. And who use it in production? Smart. Okay, so I will provide a brief introduction to what WebAssembly is, okay? And why it was created, main goals. And let's start then. So, but first, a bit of history about WebAssembly. Was first announced in 2015 and by Brendan Eich, so the dude who created JavaScript in 10 days, okay? But he was also accompanied with Mozilla, Google, and Microsoft to create WebAssembly. And the first release of WebAssembly was in 2017 in all major browsers. It was officially declared as a worldwide web consortium, whatever standard, in 2019. And till this day is being actively developed. Okay, but what is WebAssembly? So WebAssembly, I'm going to read that, is a binary instruction format that enables near-native web performance for a language like C, Rust, and so on, through a common compilation target. Now you guys know what WebAssembly is, okay? Okay, let's make it simpler. So, you have your source code with your favorite language, okay? Go, Rust, C, C++, whatever. And then you compile it into a WASM binary. In the WebAssembly world, they also call these WASM modules. And then the WASM modules will run on the browser. That's it. You see no JavaScript, no HTML, no CSS, no nothing. This is the simplest way to explain WebAssembly, okay? So, and why was WebAssembly created? Well, to start, it was created to be fast, efficient, and portable. Fast because, as you saw, it can run at near native speed. Efficient because it was specifically designed for the browser, and the binaries, like we're gonna see next, are very small. And portable because it can run on all major browsers in all operating systems. Be readable and debuggable. WebAssembly is a binary format, like I mentioned, but also has a low-level assembly language called WAT. It's mainly used for debugging purposes, but people like to use it as well. But nobody codes on that, okay? It's assembly. To be secure, and security is one of the main points of WebAssembly, because let's face it, if you are running code on a browser, it needs to be secure, right? You go to a multitude of websites and you need to be secure. And how it's secure? It's secure because it runs on a sandbox environment inside your browser. And like other web code, it will enforce permissions and policies, and from the start, it's like a deny all to everything, to your resources, to whatever, sandboxed. And last but not least, it was designed to don't break the web. So it needs to have backwards compatibility with all the web technologies that currently exist. Okay, and now you ask, okay, but do people use this? There are people using WebAssembly to create stuff. And yes, they are. So, for example, Figma, Google Earth, AutoCAD, which is a 3D CAD software, and Adobe Photoshop, all the web versions of these are currently using WebAssembly. Some in Rust, some in C, some in C++, and so on and so on. If you want to find more stuff using WebAssembly, just go to madewithwebassembly.com and you're going to see more projects for it. Okay. So WebAssembly is fast, efficient, and portable. Does this mean that I can run it somewhere else? People start to think about it. Okay, why only browser? Why can't I run this somewhere else? But where? Where can we run this? Everywhere. Basically everywhere. And how? All thanks to WASI. So, WASI, or WebAssembly System Interface, is a standard interface that allows WASM modules to interact with system resources, like file system, network, and so on and so on. So now imagine the possibilities of you having one binary, one source code, one code base that can run everywhere. But now you start to think, okay, but don't Docker does that? Don't Docker, like you have a code and then you create several images and then you can run everywhere? This post from Solomon Ikes, and this is a quote that is very shared between the WebAssembly world. And Solomon Ikes, I don't know if you guys know who he is, but he's one of the co-founders of Docker. Okay? He basically said, if WASM plus WASI exists in 2008, we would have needed to create Docker. That's how important it is. WebAssembly of the server side is future computing. I don't agree with this, okay? Neither does he, okay? It will not replace Docker, in my opinion, and on Solomon's opinion, but they will work together. They will work together in the sense of, we're going to use Docker with the WebAssembly capabilities, performance, and updates that it brings to the technology world. But how? So we have Docker, okay? Most of you know Docker. So packaged code, it has a high portability. It has the runtime isolation, thanks to namespaces and C groups and so on. It has a bigger ecosystem, like huge. And then it can have scalability thanks to container orchestrators, Kubernetes, and so on. But then we have WASM, also packaged code. It has high portability, like we saw. It has reduced resource usage, high security through the sandbox, and then native performance. We just merge these together. And the merge of these together basically is to put a Docker to put a WASM model, inside the Docker container. That's it. Okay. But then you start to having a lot of modules, okay? And you need to run them somehow. And let's face it, we have Kubernetes, and we need to run in Kubernetes, right? Because why not? That's what they pay me. But first, we need to understand how runtimes work inside Kubernetes. So we have Kubernetes, right? And then Kubernetes normally has the default runtime, which is containerd. Containerd is a high-level runtime. So it manages the container cycles. Then we have shims and runc, or rank. I call it some runc. You guys can use it rank, okay? And most of the people think that it's containerd that creates the containers, stops the containers, deletes containers, and so on. But no, it's runc. So imagine containerd is a big boss in an office that tells orders, and these are the poor guys that need to execute the orders, okay? Basically, that's it. And then the shim is a process that sits between the boss and the poor guy, like the secretary, let's imagine, that interfaces between them. So containerd basically doesn't know what's running here. This brings the possibility of, from the low-level runtime, which is the runc, to have other runtimes. For example, WebAssembly runtimes. So we have containerd, and then a WASM shim, a new secretary, which will talk to the WASM runtime that will then run WASM modules. And it's all thanks to runwazi, which is a library that you can use to create this process, the WASM shim, to interface and interact the containerd between the WASM runtime. And, okay, I put this here so that you guys can understand that developers can't do logos. So, run wazi, okay. And then there are already several runtimes, okay. We have WASM reg, wasmer, wasm time, spin, and so on, so on. And these runtimes basically offer the isolation and protect system resources from the start, like we mentioned that WebAssembly does. So going back to the two runtimes. So we have the normal flow, which is this that you guys are normally using on Kubernetes now. And then we can start to having something like this. Custom shim, custom low level, that runs WebAssembly. But we can also have this. Another shim, another custom runtime that runs WebAssembly. This means that you can have multiple runtimes now inside Kubernetes. This opens the possibility to run a lot of things inside Kubernetes. So, putting these all together, and this is the title of the talk of trying to put Kubernetes and WebAssembly together. So, we have the deployment YAML. This is going to have your Docker image with the WebAssembly module. And then in the deployment YAML, you're going to reference a runtime class. And the runtime class will point to your nodes that have the custom runtime installed. Okay? In your cluster, you can have multiple node pools with different runtimes together. Now, the funny part. Disclaimer, I'm not a backend developer, I'm not a Rust developer, so let's build a Rust app. Okay, can you, no, you need to. Okay. Can you see it? Yeah. So basically, I created a new Rust app with cargo new, okay? And it will create this code. And let's maybe change it like hello Cloud Native Lisbon. Okay, save it. Now, okay, do you want me bigger or you can see? Can see? Okay, cool. So you have the Rust app, okay. So if I do cargo run, this should be hello Cloud Native World, Cloud Native Lisbon. Okay, let's then compile this into WASM. So as you can see, the target, which is the architecture, now is WebAssembly. And to have that target, you need to install it first using Rust app. And everything that I'm going to do through this demo, I have created a workshop. It's on my GitHub. You guys can do it later if you want. So if you don't understand it, feel free to contact me later. It's all in there, okay? So we create a new binary. And then, as you can see, it's created here, binary with .wasm, okay? And now, we can already put it inside the Docker container, but we also can run it right now with WASM runtime inside our computer. I'm going to use the WASM Edge, which is a runtime that I showed. And if we run it, a local native Lisbon. Okay? So no Docker container, no nothing, straight from the WASM binary. You can run it inside your MacBook, Linux, whatever. Okay, but let's then build this into a Docker because we need to deploy it inside Kubernetes, and let's do it. So I already have created a Docker file, and the Docker file is very simple, as you can see. So from scratch, nothing, just copy the binary and execute it. That's it. So Docker build. I put the CNL, okay, Cloud Native Lisbon. If you guys don't know ttl.sh, basically it's a temporary Docker registry that you can use, and the images will stay there depending on the tag that you put. So, for example, here is 1 day. So it's finished. If I go to Docker images, let me put this more on the top. You can see it has 24 hours because I didn't change anything, because I need to test the demo. But basically, it's here. And if we inspect the image, you can see here architecture WASM OS WASI. Okay. Okay. Cool. Let's run it in Docker before we go into Kubernetes. So as you can see, I'm gonna use the runtime WASM Edge. You need to put it here. Docker will not detect that you are using WASM right now. Also with the platform. And then if you run it, you should obtain the same outcome. Hello Cloud Native Lisbon. Okay, cool. Let's push it because I need to download it in Kubernetes. Please demo gods. Okay, done. And now, I already created a Kubernetes cluster, okay, because it will take some time. But it is here with 2 nodes, and it's empty, okay? So just the main kubesystem pods. Okay. So we have the Docker image, and we have a default Kubernetes. Like I mentioned in the talk, we need to put the runtimes inside Kubernetes, right? There's a tool called QWASM or KWASM, okay? Which basically is a Kubernetes operator that will automatically modify your nodes to provide the runtimes. So I already added the repo, okay? But it's as simple as install the operator. Okay, operator is installed. And then if I check the pods, it's only one single pod. Okay, but this didn't do anything yet. What I need to do is I need to annotate the nodes to tell what nodes will run WebAssembly modules. And after I annotate the nodes, it's not this, sorry, it's this. If after I annotate the nodes, the operator will start working and modify the nodes. So if I go now to here, yeah, you see it created the job for each one of the nodes, and the nodes now are ready to run WebAssembly modules. Okay, cool. Cluster is ready. We just now need to deploy the application and the runtime. So let's go in this and go into my deployment file. So deployment is very simple. Normal deployment, okay? And then the specific thing that you need to mention here is this. Runtime class name. So you need to specify what runtime that you need. And this runtime class name comes from an object in Kubernetes that's called runtime class. So you create this runtime class called WasmEdge that will tell Kubernetes that every time a deployment pod container is asking for this runtime class, use the WasmEdge handler, the runtime. So let's deploy, check if we don't have any, okay. Okay. Runtime class installed. Let's then see if we have any pods. No. Let's then deploy the deployment. Okay. And it's here, completed. The pods will continue to restart, okay, because I created an app where the process will do an exit code 0, so it finished, so it do a complete restart. It's not a continuous process, okay? It's a Kubernetes thing. But if we go to the logs, we can see hello Cloud Native Lisbon. So we effectively managed to run WASM, WebAssembly inside Kubernetes. Thank you, Demogods. Okay, going back to presentation. So throughout these 2 weeks of hard pain, I encountered some challenges. The first one is the complexity of the tooling right now on the WASM ecosystem, which is, for example, in Docker, use Docker build, and you build a single image for any kind of language. So use just one command and for all the language, sorry. But for WebAssembly, you have to have a specific compiler for Rust, a specific compiler for Go, a specific compiler for C, and so on and so on. So there is no standard, let's say. Then some WebAssembly runtimes do not play along. I mentioned a spin runtime. I tried to create a spin application using the Spring framework, which will run on spin. And then I tried to run that WebAssembly spin app using another WASM runtime, and I couldn't, okay? But I can run this Rust app that I show in WasmEdge in WASM time. So in the end, what WASM time do I choose if I want to build an application, okay? Do I use spin? Do I use WASM time? Do I use whatever. The wrapper for containerd seems hacky. So the one WASI that I was talking about. This is because, yeah, Docker and WASM work well because right now, probably most of you don't want to change everything on how to deploy it, eliminate Docker completely, containers, right? So the transition to WebAssembly right now with the help of containers is good, but I would like to see if we could run WebAssembly modules directly without containers, okay, inside Kubernetes. WASI is still in preview, so this might not seem the ideal place for enterprises to use this. And then ecosystem maturity. A lot of things are being built, which is great, but it didn't reach yet the Docker point. So, what's the future of WebAssembly in the cloud native landscape? Yeah, I don't know. I can't predict the future. I really don't know. What I do know is that this is still cutting edge, okay? It works. It might not work for complex systems. And like I said, the real benefit that I see here is that if there are some specific cases that you need to use one single code base to run on a lot of different systems, great. Start this, test this, help WebAssembly ecosystem. And also, if you guys don't notice, if you go to CNS landscape, you guys may know, there's this here, okay, if you're not aware. So people are starting to notice this. They are starting to build this here, and will probably continue. But try it. That's what I have to say. It will be the future. Probably. The future is now. No. Okay. That was it. Thank you. So you have my link tree there on their QR code. You have my talks, my videos on YouTube, my articles, GitHub with this workshop. You have a lot of stuff there. And now it's time for questions, if anyone has.